Swayam Prabha. Digital India. Educated India.
So welcome back again. This is a new chapter, soil structure and phase diagram. This is what we are going to discuss today. We are going to discuss the porosity, the saturation of water, void ratio. There is many definitions. And after the definitions, you will know some relationship among the different variables, mostly related to soil or dam type materials. That means the granular materials. So you can see the picture here. This part is soil. I think you have seen, everybody has seen soil. So it is made with grain. If you have not seen it properly, or with a scientific eye, I will request you after the class or maybe tomorrow, you go to a garden and see the soil, take something in your hand and see and look at it very carefully. Look at its texture, its grains, its porosity, because those are very important aspect of the properties of material. Soil definitely, and there are many rocks which are like that also. Apart from that, in mining, we have what we call dumps. That means the broken material of surface mine, the blasted material, we dump it in some place, and those are huge dumps. Sometimes 1 kilometer, 2 kilometer long. It's a huge area it covers. So the behavior of those materials and their stability also depends on these properties, what I'm going to tell you today. So this is one picture. Now if I come down, these are all taken from internet, so you can find it in there. See, that is why I want you to see the soil. This is a schematic diagram though, but you will see there is some non-porous part. That means you'll not see any pore spaces here. If I show you, oops, it is very slow. Okay, I got it. So this part is non-porous, and this is a very porous. Sorry, this one is the porous or permeable. This is you can see they're telling you that this is porous but non-permeable. Meaning what? See, the porosity is there. That light blue colors are the water space or air space. And then, but they're saying there is no interconnectivity between them. So there is no connectivity from here to here. So that's why they're saying water may not permeable through this. But in this area where porous and permeable, water is permeable, means it can move, it can flow. So if I have to put it into a, I will draw it for you also, but this is also got it from internet. That is the same thing which I'm going to draw. So if you see a piece of or a sample of soil, it will have these three spaces. One is solid, which is the grain. Another space will be taken by the water, that is the pore space, that will be taken by water. And some other part of that pore space, which will not be filled in water, those will be air. Now, if you go there, you can see the volume wise, there is one volume side, there is one weight side. Now, if you see the volume side, there is solid volume, there is water volume, and air volume. But if you go towards the weight side, the weight of the solid, weight of the water, but there is we basically presume 0 for weight of the air as compared to solid and water. So what you can see is the volume of void is basically VA and VW together. Air volume and the water volume together is volume of void. And here, if you see the weight, in weight, this will not be considered. So air has the volume, but no weight. Remember that. That creates the confusion. Okay, while we will do the some definition as well as the calculation. Okay, now I will go to here what we did, I think, last time also. Okay, last time I had drawn that, if you remember this. So there are some grains. There are some grains and some space, which will be this blue color space here given. They may be water filled or they may be air filled. And the grains can be connected by adhesive or not. That is also will come in the part of solid. Okay, now if I go and if I draw that again.
So what is the green part?
What? The grain is that solid grain, maybe sand grain or the mud grain. This is it, mostly basically sand. So what I'm asking you, after the class or tomorrow morning, you go in your outside, you find a piece of soil, you just take in your hand and look at it. Okay, you see its texture, how it looks, its color. Then you will see this porosity. This is what I'm talking about. There is a lot of pore space, and those pore space contain water. These days, rainy season, so you will see it's completely damp. It may be completely filled with water, maybe partially filled with water. So partially filled means there are some air is also there. Okay, and the grains are the solid part, which mostly made with sand particle in our case. Now you write down some definitions. First is what I will tell you is the porosity. But first I draw that one again for you. Whatever. So what I have drawn to you is T part. This is solid, water, and air. Okay. And if I write here weight side, weight. This computer is giving me trouble. So we have this is W of water and this is W of solid. And this is basically 0. There is no weight. But in the volume, we have this is volume of air. We have volume of water and we have volume of solid. And this volume we call volume of void. Okay. It may be coming to you little delayed, but you can relate it gradually. Okay, now what is porosity? First definition. porosity. This we define by a parameter called P, and this is volume of void by the total volume. So total volume is this. This is we call porosity. Volume of void, that means volume of air plus water divided by the total volume. This is called porosity. Okay, this is the first definition. Now, second definition is void ratio, and this is defined as V. Basically, this is defined as V, defined by V. This is volume of void by volume of solid. See, this is a ratio. So volume of void divided by volume of solid. Okay, so I can quickly write, okay, the porosity is equals to, you can prove it also, V by 1 plus V. Okay, by this definition, this is basically V. So porosity is equals to V by 1 plus V. How we will prove that? You can prove it, right? Everybody? Just you have to replace the Vs, or you have to replace the V here. Okay. You replace it by VV plus Vs and then divide it by VV. Then you will get V by 1 plus, divided by Vs. Then you will get 1 plus V. Okay. Next definition is degree of saturation. Degree of saturation. Say these days rain is happening, and many people ask, is that the soil is fully saturated? You know, this is the question, that whether the whatever amount of water the soil can take, whether it has completely filled or not. So the degree of saturation basically we give in percent. How much percent? So the definition is, we normally define it by, I use another pen, S, and it is written as volume of water by volume of void. Okay. Volume of water by volume of void. So now if I say the S is 1, what does it mean? Or 100%. What does it mean? The entire void volume, that means the pore spaces, are filled with water. Okay. Now, if there is a 2 days rain continuously, let's say what happens in Mumbai or in Bihar or in Assam, what happens after maybe a few hours of heavy rain, all the void spaces are filled. So there is no space for water to go anymore. After that, whatever the rainfall occurs, that water we call the surface runoff, because they have no place to go underground. They will flow through the surface, and those water gradually accumulates and accumulate and create the flood. If there is a space to go underground, then you will not have a flood type situation. You see, after a few hours of rain, nothing happens because the pore spaces are getting filled with water. Okay. But if it continues, then only flood happens because it has no space to go underground. It is completely filled. So that time we call it 100% saturation. Okay. So A is equals to 1. That means the entire volume of void is filled with volume of water. Okay. So the void ratio is also a ratio which is VV by VS. So how much void volume with respect to solid volume, and porosity is void volume divided by the total volume, okay, of that oil sample. Now we come to the weight side. These three are the definitions: porosity, void ratio, and degree of saturation. This is from the volume side. Now we can define towards the weight side. First is we will write water content. Okay, and that is we write by W, small w, water content. This is weight of water by weight of solid. This is also kind of a ratio, weight of water by weight of solid. That means with respect to solid weight, how much is the weight of the water? Now, as you know, the weight of air we are ignoring. So this is water content is W by W, the weight of water by weight of solid. Now, normally when you receive a water sample from some company and they want us to do many tests, first thing we do is find out this water content. So what do we do? Once we get this soil sample, we take a small piece of that sample, we take a weight. Okay, that's the weight with water. Then we put that sample in the oven and we dry it so that water goes away. Then we take the weight again. So we get the dry weight. That become our WS. So, and the previous weight what we have taken, it's W water plus WS. So from that we can find the how much water was there. So we find out the water content. And later on I will tell you how it is related to degree of saturation. So always remember that degree of saturation and water content are two different things. Degree of saturation is related to volume and water content is related to weight. Okay, so they are two different altogether, two different parameter altogether. Okay, then we will define what is called bulk density. This is, you may write, all of you know the unit of density. What is the unit of density? Before I write the equation. Unit of density. It's not a trick question. You will definitely know.
Gram. Kg per meter cube.
Kg per meter cube. Fantastic. This is the unit of density. So we'll write this is the mass per volume. Now you see, I purposefully didn't write W. W is weight. That's why I've written mass, M. Okay. Now, if I write instead of this, if I write bulk unit weight, bulk unit weight, and normally we define it by gamma. This will be W by V. Okay. So it's very easy to remember this into rho G. Okay. So we normally work with unit weight. Even we sometimes do not express, at least in mining, we do not express with densities so much. So we call it kilo Newton per meter cube. This is the unit we normally use, kilo Newton per meter cube. And this, as you said, kg per meter cube. Okay. So we normally go by this, kilonewton per meter. Okay. In unit weight term. Okay. And another, the last one is what we call the grain density. That is very important. We will be using that in a lot of equations. Oh, sorry. Grain, we also call density, but sometimes use at a specific gravity. We will be use the specific gravity thing, but let us define grain density. So this we will define rho of S. It is still in density. So this is basically ms by Vs. Means the mass of the solid divided by the volume of the solid. Okay. And similarly, if you write grain unit weight, it will be weight of the solid divided by the volume of the solid. Okay. So these are the definitions. Mostly the basic definitions what I have given you. Now let me ask you and give you maybe a just 1 minute. Let's see whether you can prove that. And if you can prove it, you just say yes, I have done it, because I have to believe you that you have done it. Gamma of D is equals to 1 minus W of gamma. Now this D means dry, and this gamma I already defined here, and this is water content. So dry density can be related to 1 minus W into the unit, sorry, dry unit weight can be related to 1 minus W into unit weight. And this is the moist unit weight. This is dry, and this one is moist. I'm giving you 1 minute. How you are going to prove? Anybody can tell me? Dry unit weight can be related to this. Can anyone tell me what will be the definition of gamma D?
Weight of the
Weight of solid divided by volume.
Weight of solid by total volume, right? Okay, good. Can you start from here and find that out? Now, what is gamma? I already give you the total weight by volume. So niche already volume is there. Now you have to just relate to that. I'm writing it. Ws by, see from this definition, from here, we can replace V, W by gamma, right? You can replace that. So this become gamma into Ws by W, right? Now what is Ws by W? If I may come, sorry. What is Ws by W? See here. Can you write from here Ws by W? Anybody can write? So
1 by
we can write.
W.
Yeah, tell me.
Sir, it's 1 by 1 plus W.
Yeah, this Ws. Okay, I break it up. This is Ws plus W of water. You agree? So this become, you can now check, gamma by, I divide it by Ws. So these become 1 plus W. Okay, or this can be written as gamma into 1 plus W minus 1. So this basically, if you ignore the all higher order terms, you know, this can be written as this. Okay. Everybody got that? So what you simply have to remember, when we get the moist density, that means, as I told you, somebody sent me a sample. I found out its moist density or unit weight. I take its weight, I found out its volume, and that gives me the unit weight of the moist soil. Now, as I told you, then I dry it up. I find out the small w, that is the water content. Now, once I know the water content, I also know the dry unit weight. So many times this dry unit weight is expressed. So that is the basic. After that, depending on the saturation, its moist unit weight or moist density will change. Now, in order to do that, we in order to find this grain density, okay, it's not so easy. You remember that somebody has given you a soil sample, and there are some part of that soil sample is porous. Now I ask you this way, how do you find the volume of that pore space? I give you a piece of sample. Let me even draw you that piece of sample. Let's say somebody give you a cylindrical sample, and there are a lot of grains here and many void spaces. So how do you find out this void space here, the volume of void? How do you find this? Any idea?
Sir, we will fill this with water, and the volume of water will be equal to volume of or weight of the water.
You will what? You will do?
We will make
Submerge it
it
into
wet.
water.
We will make it wet with water, and we will measure its weight, and whatever will be the difference of weight, that will be its volume, because density of water is 1.
Okay. So what he is saying, if everybody has listened to him, He's saying he will first weight that sample because that weight will be required. And then he will submerge that water for some period of time. And he expects in the all the pore spaces that water will get into. And then he will take that sample out from the water. Somebody has to mute your this thing. So he will take out from the water, and then he will take the weight again. So whatever is the difference, that is the difference of water weight. And then since he knows it is 1 gram per cc, so he will know the volume. So is that a right way to do? Yes, this is one of the way, provided in all the pore spaces is accessible by the water. Otherwise, even if you put it inside the water, the all pore spaces may not be filled with water. There are some space will remain with air. Sometimes people have tried by giving some pressure, also pressurized way, so that water gets into. But that way you have a chance to break the sample also. Another a problem with this is sometimes the material may react with water also. Okay, so when the material will react, then that may dissolve. Okay, so you cannot do like a calcium carbonate type of thing. This will react with the water, so you cannot submerge. So sometimes we use brine solution rather than water solution. We put some salt and all this and sometimes some other chemical also, so that it doesn't dissolve or doesn't react rather. That is one of the way definitely. But what do we do in the lab to find out the absolute porosity? Absolute in the sense we want to find out all the air spaces also where this water cannot get into. That also, if you want to find it out, so what do? We first measure the dimension of this piece of whatever the soil they have given. So we measure the diameter and we also measure the length. Okay, and then we find out the volume of this entire sample, or we call it bulk volume. So this will be pi d square by 4 into L. Okay, so we find this volume and then we measure its weight, and that gives us what we call the bulk volume, or we call it gamma D. Sorry, what happened here? It should be D. Means we are assuming this is a dry sample. Okay, so this will become 4 Ws by pi d square. Okay, we are assuming it is this. Sorry, L. So this is our what we call the bulk dry density. Okay, the sample is dry. Then we make it powder. Powder in the sense we break the sample out completely, and we make it to the grain level. We do not break the grain. We go just before breaking the grain. We go. Means you are not going to break a sand. Okay, don't make that powder, but it should be sandy only. And there is something called a pycnometer. A bottle is just a pycnometer bottle. If I can draw it, it's something like this. A small bottle which basically take about 50 ml of total volume. And we take the empty weight. So this is the empty weight. So this is W1. You will do this experiment when you are here. If you would have been in the campus, you would have completed this experiment by this time. So I don't have to then explain. Then after taking this weight, empty weight, and we have made the powder this thing, we pour this powder in. So this powder will be here. We pour it in and we take the weight again. And that we call W2. Okay. The W2 is empty bottle plus the that sample. Then we fill it up with water. It's not coming. It's coming. We fill it up with water. Okay. And we take the weight again. So that we call W3. Okay. That we call W3. Then we throw everything out. Okay. Then we throw it out and fill only water. Then this bottle will be filled with only water, and that weight we again take, that is W4. So is that clear? The 4 weight. The W1 is empty bottle, W2 is with the sample, W3 is sample plus water, W4 is only water. Okay, these are the 4 weight we have to take, and these weights are mostly in gram. Okay, because the sample bottle is hardly 50 ml. So this is in gram. Now I ask you this. You tell me what is W2 minus W1. What does this mean? Let's say we are in mass. You tell it in some. This is what? M of mass of grain or the mass of solid, right? Everybody understand that? Yes or no?
Yes, sir.
Yes, sir.
Yes, sir. Good. Now I write one more thing. W4 minus W1. What is it? W4 minus W1 is the weight of water, complete, filled, the entire bottle, right? Okay. Then minus W3 minus W2. What is this? Or what is W3 minus W2? This is sample plus water. This is only sample. So when I'm subtracting that, so I'm getting the weight of water which is filled the bottle other than the solid volume, right? This is this part. And this is the complete, the total. So when I subtract this, what do I get? This water, this weight. This is the weight of water occupied by the volume of that solid. Okay. This is that in that solid volume, whatever space it has occupied, in that particular area, if water is filled in that particular volume, rather, not area, then that particular volume, if the water is filled, then how much will be its weight? Now, since this is, we are writing in gram per cc, and we know the water density of water is 1. So if I write the specific gravity of solid is Gs, so multiply by that 1 gram per cc will give me this. Everybody got that?
Sir, this one, can you explain once? I just missed it out.
Okay, you just missed it. Now, you understood this part, W4 minus W1. This is basically
Yeah.
empty bottle plus water. This is empty bottle. So W4 minus W1 is the weight
Only
of
water.
water, only weight of water of the complete bottle. Now, when you do W3 minus W2, this is basically bottle plus sample plus water. Okay. And this is bottle plus sample. This one. So when you do W3 minus W2, this gives me the volume where other than the sample is there, right? This one is giving other than the sample volume, because the water cannot get in there because there are sample. So it is giving me the rest of the thing. How much is this? Now this is the total. Now when I subtract that, this give me a weight which is filled by the water, sorry, which is filled by the solid. So this gives me the weight of, or the weight of the water which we'll get if it is filled in that particular solid volume area, so in the solid volume space. Okay, so now if I say this is one GS, its specific gravity is GS, the specific gravity. Okay, and then if I multiply by with 1 gram per cc, okay, then I will get what? I'll get it that in that particular space, in that watery, sorry, in that sample space, what is this volume? I'm getting the volume here, or rather it has to be basically divided. I think it should not be 1 gram per cc. So that this gives me the volume of that solid particles, that the total volume it is given. So now I can find out, I will ask you what principle it is following, and you know that principle. So now what I will know this GS, oh, sorry, sir. GS, I will be able to write, if I write with mass, in the book I have written with weight, so you can always write it with this thing. So this is nothing but is basically Vs. So this, right, I missed it there. This will be Vs, volume of solid. So this is that specific gravity. This is the volume of solid, which space it has taken, and this is the 1 gram per cc for water. So if this should be multiplied by, if you are mentioning it in gram, so this is basically that 1 gram per cc. Okay. So that it is coming to the specific gravity. So this is giving me the specific gravity of that solid. Okay. So what is the process now? I repeat again. You first take the sample, you crush it, and then we have a pycnometer bottle which is 50 ml like this. We take the empty weight W1, we fill with that powder of that solid, and that gives me W2. Then again I filled it with water, that gives me W3. Then I throw out everything and I clean it. I fill with water and I take the weight again, that's W4. So W2 minus W1 definitely is the solid, which is my MS if you are doing it in mass in gram. So that I already know. And then W3 minus W2 is the space where other than the solid volume, the water is there. And when I do W1 minus W4 minus W1, it is the total water volume. So when I subtract, I get the volume it has occupied in that Vs space. What is the volume of that that solid? Because that is which I am looking for. So now my Ms by Vs is what I am looking for, and that gives me Gs. And since it's a 1 gram per cc, so directly if you're doing measuring in cc and volume measuring in cc and mass you are measuring in gram, then it's directly W2 minus W1. This will be directly, it will give you W2 minus W1 by this entire thing, W4 minus W1 minus W3 minus W2. This directly will give you the GS. Now, can anybody tell me what principle has been followed here? What law? To do this, we have used a law given by a famous person. Just the application of this law. Huh?
Archimedes.
Yes. It's the Archimedes principle to find out the volume of any irregular or any irregular shape in object. Now here, again, you have to remember that in this case, all the void spaces I have not given you the porosity. So by doing this, we are considering that the total void volume I will be now able to capture, able to tell you. So what will be porosity now? The porosity is, because this is what I am looking for. So the porosity is 1 minus volume of solid by the total volume. If you recall, it is the volume of void by the total volume. Volume of void can be written as total volume minus volume of solid. So I can write it like this. Now you can see this one, I can write 1 minus, even if I'm writing in now in weight format. So WS divided by gamma W. That's why this is now coming into GS. This is in the below. And in the bottom is WS divided by gamma D. This is gamma D. Okay. Now what I have written, GS is WS here. You are taking this VS here up there. So it is basically, I'm now writing with the W. So this will be WS divided by GS into gamma W because I'm writing in weight. So this one will come in the top instead of VS, and instead of V, which is the total volume. So this is the solid divided by gamma D. Now what is gamma D? Gamma D I showed you, but that is that sample. Let me show you here. This sample thing we have already done here. You see here, we have already done. This is already done. This is prior to crushing the sample. You must have calculated this. Okay. So once you have this, then it is very easy, isn't it? Then porosity become. Yeah, okay. Now the porosity become. Now all this will cut. So I will get 1 minus gamma of D by GS into gamma W. Okay, this is basically D. D didn't come properly. Let me write it again. So now everything I know. This we have calculated prior to crushing the sample because we know L and D, diameter and length. So we could calculate that. This we already know 1000 kg per meter cube. Okay. Or if you convert it into this thing, then the kilonewton, 10 kilonewton per meter cube. This I already know. And GS, I just find out from here. So the porosity can be estimated using this. Once I know the porosity, I can calculate the void ratio. There is a relationship. Let me give you some particular number. Like for sand, okay, this will be about 2.65, this GS. Okay, let's say if you go towards if I give dolomite, which is 2.8, if you go even limonite, where there are some iron is there. Limonite is a material, let's say powdery material. It's mixed with, you sometimes you have seen the red soil, right? That red soil contains some iron content. And those iron content, if is there, its grain density increases. It's become from 3.6 to 4. Okay, so there are some ballpark area. No. Okay. I can give you a quick problem if you like to do very quickly. If you have the calculator and everything in front of you, then diameter is diameter of the sample is 22 millimeter. Length is 35 millimeter. Okay. And the weight is the dry weight. The dry weight is weight dry is 30 gram. Okay. Using the pyknometer, we found W3 is 91 gram and W4 is 72 gram. And question is, can you find the porosity? I think everything is given here to use that formula. So you have to find out first the gamma D, which you will be able to find out because you'll be able to calculate the volume from here. Weight is given, so this calculation is very easy. You'll be able to calculate. Then W3 and W4 given, and this is basically your W2. Okay, this is basically your W2. So you can basically W1 minus W2, you can take that 130 gram already. So you can directly use this this formula to find out the GS, and once you find the GS, you know the porosity. And in this case, it has come porosity is about 17%. So 17% volume is porous of that soil. Okay, of the total volume, 17% of the total volume is pore volume or the volume of void. All right. The last thing before we go today, we are going to derive one basic equation or the fundamental equation for weight volume relationship. And this is one of the basic equation. If you know that equation, all of the other thing you will be able to do. This equation is I'm writing the equation and then we'll do gamma. That means the moist unit weight. This is the moist unit weight is equals to 1 minus porosity 1 plus water content multiplied by GS into gamma W. Let me write it again. Gamma W. Oops, something wrong. So gamma of moist unit weight is equals to 1 minus porosity into 1 plus water content into GS into gamma W. This is one of the very interesting equation which relates basically the volume and weight relationship in the porous material. Now, you will always start from the very basic principle, and the basic principle here is, or the basic definition here is, gamma is nothing but W by V. Okay, so this is the our moist unit weight. Now this one will be written as WS plus WW by V. So the total weight we are writing, we are breaking it up into solid weight and water weight. Okay. Now for the solid weight, we can we have just shown you this can be written with GS gamma W into VS. See VS into GS into gamma W, because this is a specific gravity of the grain, let's say 2.6, multiply by V or multiply by its let's say density will give you the gram per cc or kg per meter cube or kilonewton per meter cube. Then you multiplying by the meter cube will give you the weight of that solid. Okay, and this one, the weight of the water, if you go back to the relationship what I gave you, there is a direct relationship between these two. Even the ratio is nothing but small w. So I can write this is same thing but with a small w and the same thing. It is basically GS gamma W into VS. It is the same thing. And in the bottom, the total V, we can write it by VS. If I change it to VS, the reason I'm changing it to VS, you see the everywhere is VS in the top. And this is 1 plus the void ratio. If you relate to the void ratio to VS and total V, so you will find this. So now the entire VS will cancel. Okay. So take it little up. So this one finally comes down to 1 plus W GS gamma W divided by 1 plus V. And I have given you before a relationship between V and P. And so 1 plus V is nothing but 1 minus P in the top. Okay. And this is 1 plus W GS gamma W. So this is the proof. Okay. This didn't come properly. So this is a very fundamental relationship. Based on this relationship, many problems we can solve. Okay. So I will stop right here.